There, back to full screen. Okay, so we're back. So we just loaded section 1.7 into Box. So all of my current college algebra students have access to anything that you saw me writing on the screen. So there is a PDF version that's been loaded. Okay, were there any questions from that last section that we did from anybody in the house or anybody in the audience? Any questions? Okay. So it is a little bit information overload. So I know it's a little intense. This is why I don't mind open notes on my exams. And also, again, I'm going to make this disclaimer. Honestly, if you're comfortable with every question on my study guide, you should be okay for the exam. I'm okay with that. Since everything is so kind of crammed, okay? So you have the weekend, team up, get a tutor, reach out, email me, okay? Be sure that you're logged into my math lab. Make use of the tools. It's a very powerful tool. They'll walk you through everything that's there. You just want to, this weekend, just take your time. You know, you only got, 4 sections that you're responsible for. So if you did 2 sections on Saturday, 2 sections on Sunday, that's a good rhythm. You should be ready for Monday. Does that make sense? You can even do 2 today and 2 Saturday, rest on Sunday. You can do 2 today, 2 Saturday, and then review again on Sunday. That's even better. It's just 1 weekend of intensity that you can breathe for a little bit, okay? Questions, comments, or concerns? Got everybody's name on the attendance. I will update that. Let me finish this out. Yeah, this is since we've already started. Okay, so if there aren't any questions, comments, or concerns, I'm going to move forward into the last section for Chapter 1. So this section is on Section 1.8, Absolute Value Equations and Inequalities. Now, there are basically 3 main techniques that's going to come out when we're dealing with these scenarios. So the absolute value is going to be the positive distance away from 0. For instance, what's the absolute value of negative 7? 7. What's the absolute value of 2? What's the absolute value of 10,000? Absolute value of negative 3 over 7. 3 over 7. What's the absolute value of 0? 0. Okay, I was just making sure. Okay, but yeah, it's the non-negative or positive distance away from 0. Okay, so we'll let that be. All right, these are the cases. So now we're working with these absolute value equations and inequalities. There are 3 scenarios. The first case is when this one right here. When we have the absolute value of x equals, it should be some positive number. Okay, so k is some positive number. When we have the absolute value is always what? Positive, right? In an oversimplified context. So now, if we have a positive number equals to a positive number, when we have the absolute values equal to some positive number, we're going to have, I think it's like 2 solutions, either k or negative k. Okay, we're going to see how that works. Again, absolute values equal to some positive number, we're either going to have that positive number or negative of that positive number, okay? And we're going to have 2 solutions in red like you see there. That's the first case. The second case when we're dealing with absolute value, it comes with inequalities. Now, in this one, when the absolute value is less than some positive number, right? Technique I use here, I'm trying to think of how to articulate. I think it's a technique called keep, flip, flip. I'm just making this up. What I mean by that, keep, flip, change. Yeah, or keep, change, or KFC. Yeah, that's fine. That's right. So what I mean by that, let's look at it. Let's fix that. We're going to go like this is fine because we're zoomed in. Yeah, that's fine. Okay. So now, the first case is the absolute value is less than some positive, right? So what we're going to do to solve these, we're going to keep this, change this, we're going to flip this, KFC, right? Keep, flip, change. Flip this is going to flip to the other direction, and this is going to become negative, okay? So, but now the simpler way for me to do this, when it's less than, as far as I'm concerned, we're going to say negative k less than this, less than that. What I mean is we're going to do something like this. We're going to say negative k less than the inside part, less than the right. When we string that together, we get this. Okay, so again, you got to check this out. It's very subtle and it's easy to kind of lose this, right? When you have absolute value is less than, we're going to get this kind of image here. Negative k is less than x, less than k, right? That's the second scenario. The third one is, what's the difference between the second and third? It's flipped. The absolute value is greater than. So now when the absolute value is greater than, we have to do this. It's still keep, flip, flip, but you keep the original. See, the first one is we keep the original, which just drops the absolute value. You see it right there. And then we add the or, and then we flip and flip, and we get that, okay? So again, there are three cases or scenarios when dealing with absolute values. If it's an equation, we get two results. If the absolute value is less than some positive, we get this thing in the middle here. Okay? When the absolute value is greater than some positive, we get this thing going on. It's a keep, flip, flip. Okay? So now it's very subtle. When you start working these examples, it's very easy to get lost. But with absolute values, those are the three main cases that tend to pop up. I'm watching the clock. Let me get through these examples. If you have a question right now, I ask that you write it down, take a note. And at some point, I'm going to pause, and then you can ask your questions, okay? All right, and so this is one of those. Do we have any questions right now? All right, so I'm going to move forward. I know it's information overload. This is a recording, so keep in mind you can go back and pause and rewind and watch and do whatever you need to do to kind of get it to sink in by Monday. We've had this information for a while, so we kind of have to keep moving. All right, I'm going to let this be, and I'm going to work a few examples. Now, which case is this? If we're looking at this example 1, is this case 1, 2, or 3? Is this case 1? So we're anticipating how many results? 2 results, right? So what we're going to do the following. Give me a color. Purple. Okay, I heard purple. So first we're just going to rewrite it without the absolute value. We're going to say 5, and let's thicken up our lines. We like a little bit of thickness. We're going to say 5 minus 3x. We're just going to rewrite the original without it. Then we're going to say or. Then we're going to do, again, it's KFC, so keep, flip, flip, right? So then we're going to say, watch, 5 minus 3x. If you flip the equal sign, what happens? It's the same thing because it's symmetric, right? So we get that. And then if we flip the 12, it becomes... No, not like that. That's please don't confuse my students. I like the joke though, but yeah, it becomes negative 12, right? Is that okay? Okay. But we essentially did do keep, flip, flip. Or you can look at it as or, flip, flip, okay? So we just rewrote it, and then we put or, and then we did flip, flip. But when you flip the equal sign, it stays as is. We solve these two, and we get the proper result. A common mistake that students like to do is they'll do this. And I'm going to do this in red because this is a common error. I'm going to say this is a common error that students like to do. Instead of flipping the 12, they'll do this. 5 plus. That's what the 5 plus 3x equals 12, which will lead you astray. That's not right. No. That's just the first part. That's all together. Yeah, you have to say the whole thing by negative. So you have to distribute the negative. If you wanted to use that red technique, you can, but you gotta do it properly. This is a common mistake that students make in red. Yeah, the purple and orange is A-okay, and you'll be fine. Okay, so or flip, flip, or KFC. I like the KFC. Anyway, I'm gonna let all that be. But yeah. So once you get to the purple and orange, then you just solve those separate equations. You subtract the 5, we'll get 7. So the first result looks like it's a negative 7 over 3. Subtract 5, that's a negative 17. So then it's 17 over 3. So negative 7 over 3 and positive 17 over 3. Okay. And then with those results, though, again, if you stop here and you don't check, sometimes that's called the right-wrong answer. Sometimes algebraically it's correct, but you always want to check. So you just want to plug these into the original and make sure that they work. Sometimes they don't work. So, okay, I think they're checking, and they do check out. I'm going to move forward. Let me pause for the cause. Any questions at this point? Anybody have any questions? You quit school when you decide in your mind. Honestly. I mean, you never really quit school. Even if you're not in school, you're still learning something. So you might as well be working towards something that's going to become an asset. But, I mean, honestly, if you figure something out, there's nothing that really says that you have to do this. This is just what's socially acceptable right now. But as far as I'm concerned, if you're business savvy or you got some gumption or passion or something like that, where you can take care of yourself and take care of people, if you can do that. I had a student in here. I was like, man, you're wasting your time in school. This kid was the best drawer I've ever seen. I came in one day, he could draw really, really well. I came in. I got a picture. It was like last quarter. He came in. He had this very elaborate, like, just used dry erase marker. This very detailed Godzilla on my dry erase board. I don't know his name. I'm not saying names. I don't remember. But I have it all logged. I have a log of it. But this is the best drawing. I was like, kid, you're wasting your time in school. Like, you just need to keep drawing. That's all you need to do. You just need to draw. And, like, I mean, because, like, I've gone to, like, oh, yeah, this reminds me. I forgot to tell my earlier class. But the second Sunday of every month is free admission to the High Museum of Art. Well, I'm just reminding you, this Sunday this Sunday is the free admission. But I forgot to tell my earlier class. But I say that to say the stuff that he was drawing, just like on in his notebook and on the wall and stuff like that, that was way better than stuff I've seen in like art galleries. I saw stuff in art galleries. I think I told you about the football on a canvas, and they just painted the American flag over the whole thing. The thing was selling for $70,000, $80,000. I'm like, I can easily do that. It's just a football on a canvas, and you paint the American flag over the whole thing. It was on display for $80,000, and the stuff I saw this kid drawing way better. I'm pretty sure he can easily find somebody that would pay that on up. He could be doing murals all over the city, all sorts of stuff. So it's like, if you have already identified your talents and abilities, to me, as far as I'm concerned, school is for people that haven't quite figured out what they love to do. If you know what you love to do, and especially if you found how to get paid to do what you love to do, that's what it's really all about, as far as I'm concerned. So so don't get caught up in the hype of education. It has its power. Don't discredit it. It definitely is powerful, and it's definitely I will say that people that have an education and when they do become successful, they're typically happier. But the people that are successful but they have no education, they tend to lose it pretty quickly. They'll get the millions of dollars, but then they'll it'll go away, and then they'll be back to square one. So you do kind of need both of them. Okay, I'm going to keep moving. The clock right at 20 minutes. That did not hurt. Ouch. Okay, so now this one, we have an absolute value equal to another absolute value. We've already isolated an absolute value, so we essentially do the same thing as the previous one. We're just going to rewrite it without the absolute value, and then we're going to say KFC. So we're going to put or. We're going to keep the first one. The equal sign flips, where it stays as is, and then we're going to negate the entire right-hand side. So if you essentially do the same thing, it works, right? So watch. So now, again, let me show you. Give me, that color's fine. So let's look at this again. So look, we've already isolated an absolute value, so we do the same thing we did before. We just rewrite it. You see it right here. Then we put or. And then we say the left equals negative of the right. This is the exact same thing we did in the previous. No, in this previous example, the orange that you saw in that previous example is highlighted right, right here. The orange that's here is the same. Otherwise, everything is exactly the same as what we did before. Okay, so then once you get to this point, you just solve the two equations. This is the hardest part of this. Once you get here, just solve this equation, solve for x, solve this equation, solve for x, check your results in the original. Okay? So the hardest part with these is the initial setup. If you have a question, just write it down. Say example 1b, just write it down. I'm going to move forward, just for the sake of time. Okay? Just check these solutions in the original equation. All right, now, which case is this? If we're in 2a, is this case 1, 2, or 3 from those three different cases? This is case 2. So what is it going to look like? That means we're going to do, what's the far left going to look like? Negative 7 less than 2x plus 1 less than 7. Now you know what to do from this point. We just did this in the previous section. From here, subtract 1 from all three parts, and then divide by 2. You got it. So again, the hardest part is the initial setup with these, and it's very subtle because it's very easy to incorrectly interpret that. Students get lost by that. So I can see who's kind of like, I see what eyes I have command over. I know who's paying attention. This is actually a pretty good crowd. You guys are listening, so I know it's in your subconscious at a minimum. So I'm really just trying to spark lightning bulbs in your head. And so that way, when you get on your own, either something should stand out, either my audio or some visual or something. Something should trigger when you get on your own. But this is why I ask that you minimize the distractions, because when distractions happen, when you go to study, all you're going to remember is that distraction. Like if somebody were bust in the room right now, like Kool-Aid Man, all you're going to remember is Kool-Aid Man. No, this is true. No, this is true. Like the study, like however it is you study at home, when you go get on the exam, it's going to be the same. So like when you're studying, if you chew gum when you study, you should probably chew gum when you take the exam. You want to replicate that scenario because your body is going to remember. It's going to remember everything, and like it's going to trigger. But if you get on the exam and it's completely different from what you've been doing at home, it's not gonna happen. That's why students have a hard time because they don't practice. Now, I'm not saying that you all don't, but I'm saying that's why they have a hard time. But it's like if you're practicing at home, when you get in on the exam, you'll see that it's actually the same thing. It's the exact same thing.
I'm surprised that means that let me listen to music.
I'll consider it. I'm
Really?
open. Yeah, I'm open to that. Yeah, but you might have to have your Bluetooth ready because I need the phones at the front of the room. You can't be on your phone, so you're gonna have to set it and forget it. If you can control your volume with your Bluetooth, that's fine. But I'm gonna want the phones at the front of the room. I'm okay with that. Okay, but again, no. So the phones are gonna have to be at the front. You cannot be on them. Okay, so I'm open to that. To a degree, as long as I don't sense any phony business. Okay, seriously, because I don't play with my exams. Any other day, I'm all happy, lucky, playful. On exam day, I'm super serial. Okay. Let's keep going. So yeah, that was a shameless South Park reference plug kind of thing. I'm serial, guys. This is Al Gore. I'm serial. Global warming. It's South Park. Forget about it. Anyway, so now from this point in the green line, you know what to do. Once you get to this green part, you know what to do. Okay, because we just did it in the previous section. Okay, I'm going to move forward. Okay, now if we look at this example 2b, is this case 1, 2, or 3 from those 3 different cases? It is case 3. Give me a color other than green. Did I hear blue?
Yeah.
All right. So now, if it's case 3, so case 3. So now we write it like this. First, you just kind of rewrite it. So we're going to say 2x plus 1 is strictly greater than 7. We need to do OR, and then we do flip. So we're going to say 2x plus 1 is less than negative 7. So this is how I do that. I just rewrite it, then I do my OR, then I do my KFC. Keep, flip, change. Does that make sense? Okay. No, the case 2 actually does the same thing. The only difference is instead of OR, it's an and then because it's and because of the orientation, you can write it the way that we write case 2. Forget all that. Long story short, if you do what we've been doing for case 1, 2, and 3, you'll be fine. Again, there's so many different techniques and other things, but you don't need to know all of them right now. You just need at least one thing that's going to work in as many cases as possible. So here we solve each case separately, and then we got to correctly interpret the results. Now, getting to this blue line is the first level. Interpreting the results is a whole other thing, okay? So you still want to practice and make sure that you're getting these correct on a consistent basis with the least amount of support that you can. Do what you can on your own. If you can't get it, team up with your classmates. Hopefully you have people's contacts in your class. You're working together over the weekend. You have a tutor or something like that. And you can also contact me via email. I do dedicated YouTube videos for this kind of stuff. It's a much slower pace, okay? I'm going to move forward. I'm watching the clock. We got plenty of time. Let me move forward. If you have a question, take notes, write it down. We got a couple more slides, and I can entertain questions. So I'm going to leave the rest as an exercise for you. All right? So now here, how is this one? How can we make this one look like, in this example 3, how can we make this look like something that we've already done? What could we do? Right. So she said, isolate the absolute value. So add 1 to both sides. That's exactly what you do. If we isolate the absolute value by adding 1 to both sides, which case do we have at that point? Case 1, 2, or 3? If we isolate the absolute value by adding 1 to both sides, at that point, see, look, if we add 1 to both sides, we'll have 2 minus 7x absolute value is strictly greater than 5, right? That's okay. So now, if we're here, this is case 3. Now you know how to work case 3 because we literally just did it. It's the same thing. So we just keep building on these previous notions and ideas. We start with a base, and then you see that when you get to it, you're like, oh, this is a repeat of the last. It's the exact same thing with different numbers. It's the exact same thing. So again, mathematics is all about repetition. It's just about repetition, pattern recognition. That's all it's about because that seems to be what's going on. And then you can make inferences, and you get a lot of insight. Even human behavior is patterns. It's not set in stone, but you get a lot of insight. Okay, so once you identify this case 3, you should be able to take it from there. So it's a repeat of the previous. How do we write this again? It's going to be, you just rewrite it. So it's going to be 2 minus 7x greater than 5. We're going to do or flip, or the KFC. So then we're going to say 2 minus 7x is going to be less than negative 5. Okay. Solve it, and you'll see how it works. Okay, I'm going to leave the rest as an exercise. Which case is this one?
Don't you have to subtract 2?
No, in this example 4. It's case 3, right? Absolute value is always what? Positive. That's fairly accurate. So when is a positive number greater than or equal to a negative? Always, right? So what x's should work here? Any real number. Does that make sense? Any x you plug in here should make this true, because positive numbers or non-negative numbers are always greater than negative numbers. Does that make sense? Absolute value is non-negative, so any x you plug in is going to be non-negative. It's always going to be greater than a negative. Does that make sense? Okay. So it should be all reals here. Okay. In this example, in case B, it's in example 4B, it is case 2, but notice absolute value is always non-negative, or you can essentially say positive and still get the idea. When is a positive number strictly less than a negative number? It's never less than a negative number. So what real number should work here? If a positive number is if a positive number is never less than a negative, what number should make this true here? If the last one where all numbers make it true, and this kind of has the opposite feel, then what numbers should work here? Okay, so no real number is going to work here. So in other words, there's no number you can plug in. A positive number is never going to be greater than a negative, right here. Absolute value is non-negative. Positive numbers are not less than negatives. So no matter what real number you're going to plug in, it's never going to be less than a negative. In other words, long story short, no real number is going to work. No solution. Empty set. You can kind of crunch the number. If you don't see it immediately, you can still crunch that number and test it out. But that's the long and short of all of that. Okay, I'm going to move forward. Special cases. Absolute values equal to 0. Okay, so which case would this be? So suppose we don't immediately see what's going on here. Which case would this be? Which case would this be? 1, 2, or 3? 1. So you can actually work this just like 1, and you'll get to the right conclusion. So the absolute value of a number will only be 0 if that number is 0. So that means the absolute value have to be 0 in this case. So then the original is actually the same as this right here. You solve that, there's only going to be one solution, which is negative 3 in this case. If you didn't see that, you can actually work the original way, and you'll still arrive to the same conclusion. Okay, you'll still arrive to the same conclusion. If you have a question, take note on what slide it is, like example 4C. Write it down. We're almost done. We're almost out of time. Just trying to wrap it up and close it out. It's almost 1:11. We got a few more slides. Write the statement using an absolute value. It says K is no less than 5 units from 8. K is no less than 5 units from 8. So that means that K is going to be equal to 8 plus or minus 5, right? So it's either down by 5 or up by 5, right? Right? So, okay, so if we translate this sentence directly, right, we're saying K is 8 plus or minus 5, right? Let's isolate that plus or minus. I'm losing my voice, by the way. Yeah, I know. And I don't really want to be talking, but it's my job. So I'm like, well, let me just get through the end of the class. So now, let's isolate that plus or minus, right? Let's subtract 8 from both sides. So then if we say K minus 8 equals plus or minus 5, that should be the same as absolute value of K minus 8 is no less than, I might have to change it up a bit. 5 though. Might be an inequality. Yeah, no less than 5. If we subtract 5, that distance, I think it's like this. No less than. That's the only thing I'm a little bit confused about. Distance greater than or equal to 5 can be written as, yeah. Let me see. I think it's like this, right? K is, maybe not. Give me a second. If I subtract that, so they're saying that is this K k minus 8 greater than or equal to 5. So then that would be this case. So it would be k minus 8 greater than 5 or k minus 8 less than or equal to negative 5. If I subtract 8, give me just 1 second, I'm almost there. If I subtract, I get this, and I think that's correct. Yeah, I can't really articulate that one that well, so you're going to have to practice that, look at it, and figure that one out a little bit on your own. Delete. No less than 5 units from 5. Because if it were flipped, right, if k were less than that, so for instance, if it were flipped, and we said 8 minus 5, we get 3. We're saying k could be less than 3? That's not right, right? Kind of got to think of it that way. You have to do the best you can there. But I gave you enough of a background to get it. Again, no less than, so we did this. So then we said 8 plus or minus 5. We subtracted the 8, and we isolated the plus or minus. Once we isolated the plus or minus, we get the thing on the right. I know the explanation is not the best, but I'm going to have to let it be. I'm just a little scrambled because we're almost out of time. I'm trying to get everybody out on time. Okay. Let's do one more. N is within 0.1 units of 0.001 units of 6. So that means 6 plus or minus 0.1 within. So if we think about 6, if we think about 6 plus or minus tenths, hundred thousandths, 1 tenths, hundredths, thousandths, 1 1,000ths of a unit. So if we subtract that, it should be greater than, right? Within, yeah, it should be like this, right? Because if it were less than, it wouldn't work out properly. So then if we subtract the 6, it should be n minus, come on, n minus 6 absolute value. I'm anticipating this kind of thing going on. Sorry. Okay. N minus 6 absolute value greater than or equal to plus or minus a C. I knew I got that wrong. So the translation of that is throwing me off a little bit. The statement indicates that the distance between n and 6 is less than 0.1. Oh, wait. Okay, wait. Can I... Distance. Anyway, so you're going to have to synthesize that and think about that for a bit. I'm just kind of rushed for time. If we subtract that, if we multiply both sides by, I think if we multiply both sides by a negative, we get this result. Almost. It still doesn't quite work all the way out. So you have to do the best you can with that. Okay? So you have to do the best you can. Again, ours is going to be multiple choice. So, you just have to do your best. Kind of do a little bit of research, look around, ask questions. I'm going to leave this as an exercise just because I'm out of time. And I think that's it. Okay. So now, did anybody have questions? I know those last two were a little dicey. Anybody have any questions from things from before, though? Any other example? Okay, so with that, I'm going to pause for my YouTube. We're going to end the session there, and from one beautiful mind to another, enjoy the rest of your weekend. If you're my student listening in, so these notes are loaded into Box, and I'm available via email. So just email me, and I can make dedicated YouTube videos, and it can be a lot more polished, a lot less rushed, and things of that nature. Okay. So, but we'll end the session there, and from one beautiful mind to another, enjoy the rest of your weekend.